Welcome back to another video. In this video, we will discuss about the concept of gravitational mass and inertial mass. In this video, we will discuss that the both the mass are same in units, but the calculation of both the masses are different in terms of the units. Let us move ahead. Gravitational mass and inertial mass. So first we'll take the case of inertial mass. So let us assume object provided by force and it experience some acceleration. Let us take it as 2 meter per second. Now the depending on the value you ascribe, a value of the body is being defined, which is known as the inertial mass. So in this case, let the inertial mass be 1 kg. Now, while ascribing this quantity, we have taken the acceleration as 2 meter per second. Let us assume it as the first case. Now, let us talk about another case. Take a discrete object and apply the same force as the first. And this experience an acceleration of, let us assume that 1 meter per second. So 1 meter per second. So the inertial mass would become twice of the first. So it becomes 2 kgs. Now let us assume the third example. Same force, another discrete object experiencing an acceleration of 4 meter per second. So the inertial mass of this particular would be half of the first, means 0.5 kgs. So this is the calculation of the inertial mass. Now let us go to the second example, which is second case, which is the gravitational mass. So gravitational mass. So we all know that there is a property of matter which is known as charge. So if this is Q1 charge, it is Q2 charge. So it shows some forces which is attractive sometimes, and sometimes it can be repulsive too. So apart from this, there is one more property of the matter which is generally termed as gravitational force or gravitational acceleration, which are rather two different topics, but we term it as the gravitational force rather than acceleration. So point mass always exerts some force on the other object which pulls them, which tries to pull them toward the another object. So this basically is the gravitational mass of the object. Now let us take some example on how to calculate the gravitational mass. Assume this is Earth and we place a point mass from our distance from it. Let us uh, give it 1 unit of the gravitational mass and it experience the force F due to Earth's gravitational force. Now take another example. Likewise, this is Earth, and from our distance, there is a point object which experiences the force of 2F. So the gravitational mass of this object would be twice of the first, means 2 unit gravitational mass. So likewise, you have seen that the calculation of inertial mass and gravitational mass varies by difference, but the values of this comes to be same. So that's why we generally don't differentiate between the concept of gravitational mass and the inertial mass. So rather while taking the values of gmm upon r square, this masses are inertial mass basically, uh, taken as inertial mass, but this is actually the gravitational masses. Yeah, so it can be a coincidence, or to make physics a bit easy, not discrimin differentiating between the inertial mass and the gravitational mass. So this was a small little concept. Thank you for watching. Meet you tomorrow.